Okay, so I figured out where the mistake on this problem was. Thing number one, and I fixed this for 4th hour A day already. Thing number one, if this should not be t from negative 8 pi to positive 8 pi, it should be t on the interval from negative 2 pi to positive 2 pi, okay? The reason is because, like we talked about, this distance right here under one hump of the cycloid is the circumference, okay? So this distance does get us to 8 pi, but it's 8 pi in the Cartesian label. Okay, so that ordered pair is 8 pi comma 0 in terms of x and y. So, and then we have a height here of the diameter, which is 8. So this point right here happens when t is equal to 2 pi or when t is equal to negative 2 pi over on this side, okay? Because so as t goes from 0 to 2 pi, we rotate through one of these curves, but the x-coordinate is 8 pi. So t should be limited negative 2 pi to positive 2 pi. Otherwise, 8 pi, we would have 3 more humps over there and 3 more on the left side. Okay, so first of all, fix this. Now, the issue of the area, okay? So area is equal, in terms of x and y, is a to b of y dx, okay, which we already said is going to be the integral from alpha to beta of g of t times f prime of t dt, okay? Again, go back, we did this in class, so this is what y equals, this is dx in terms of f, all right? Now, I think I wrote that alpha was equal to f of a. I have that backwards. It should be that a is equal to f of alpha and b is equal to f of beta. Okay, but really, so if because over here, these are in terms of x and y, well, a and b are in terms of x and y because it's x equals and y equals, and then alpha and beta are in terms of t, okay? So really, when we write the integral under this one hump, we're going from 0 to 2 pi because we have t from 0 to 2 pi, we know that to be the circumference. So this is always going to be 0 to 2 pi for one hump, no matter what the radius is. But if we were to write it in the Cartesian coordinates, then we would be going from negative, or we would be going from 0 to 8 pi, okay? Because that would be 4 times 2 pi minus sine of 2 pi, okay? You don't actually have to do the inverse of the f function to figure this out. We can just know, hey, the limits these are already in terms of t, are going to be 0 to 2 pi. Okay, so then filling the rest of it in, we get g, which is 4 times 1 minus cosine t times f prime, which is the derivative of this, 4 times also 1 minus cosine t dt. Okay, taking the 16 out, we have the integral from 0 to 2 pi of, I'm going to square 1 minus cosine t, so that's going to be 1 minus 2 cosine t plus cosine squared t dt, okay? And then from here, we can split this into 3 integrals. Remember, the 16 goes to all of them. We are going to have to use the half-angle identity on that part. So if you remember, half-angle identity is that cosine squared t is 1/2 times 1 plus cosine 2t, okay? So this becomes 16 times the integral from 0 to 2 pi of 1 minus 2 cosine t plus, and I'm doing the whole half-angle identity in here, so 1/2 plus 1/2 cosine of 2t, then dt, okay? And I'm writing it like this instead of the 1 plus cosine 2t because I'm going to combine this 1/2 with the 1. So we then have, as an antiderivative, this is 3/2, so we now have 3/2 t, okay, minus 2 sine t. And then for this one here, is 2t, meaning we need to multiply by 2, divide by 2 also. So we end up with plus 1/4 of sine of 2t from 0 to 2 pi. Okay, now we're evaluating 16 times the quantity. So 3 over 2 times 2 pi is 3 pi. And then minus sine of 2 pi, sine of 4 pi are all 0. And then if I plug in 0, I still get 0. So minus 0 plus 0 minus plug 0 in, we get that. Okay, so we end up with 48 pi as the area. Then for the last one, where we're looking for arc length, I'll go ahead and finish this one too. So arc length we know to be the integral from alpha to beta, or a to b, doesn't matter, of root, and this is f prime of t squared plus g prime of t squared dt. And it doesn't matter if you use this notation or if you put like x prime of t and y prime of t, or x prime, y prime, or Leibniz notation. Either way, we're using this formula, and again, this is from 5.4. Okay, so we're going to do the integral from 0 to 2 pi, because again, we're doing one hump, which is from t equals 0 to 2 pi. So it's okay. So then we have the square root. Okay, so f prime is going to be 1 minus cosine t, and then, oh, I forgot the 4. 4 times 1 minus cosine t, and then that whole thing is squared, plus, and then y prime, so y is 4 times 1 minus cosine t. This derivative is 0 plus sine, so we have 4 sine t, and then that whole thing is squared dt. All right, and then, because it's better when we factor, I'm going to take a 4 squared out from under the radical, so I'm going to put a 4 in front of the whole thing, and then we have the integral from 0 to 2 pi of squaring this. We have 1 minus 2 cosine t plus cosine squared t plus sine squared t. And then, using this Pythagorean identity, that's equal to 1, so we end up with 4 times the integral from 0 to 2 pi of, so this is 1 plus 1 is 2 minus 2 cosine t dt. Okay, this is almost exactly the same as the half angle identity for sine squared. So just as a reminder, sine squared of t is 1/2 times 1 minus cosine of 2t. Okay, and so I can factor a 2 out of there, or another way to look at it would be I can rewrite this by multiplying and dividing by 4 on the inside. Okay, so think of it as the square root of 4 times 1 minus cosine t over 2 dt. Okay, and then using our half angle identity, this is 4 times the integral from 0 to 2 pi of the square root of 4 we still have here, times, and then this is the square root, we'll keep that together as 1. So the square root of 4, this 4 right here, copied over here, but then this right here is sine of t over 2. So sine of t over 2, okay, from this angle, or half angle identity here, okay, oh, sorry, sine squared, and then dt. Okay. So, square root of 4 is 2. We have a 4 on the outside, so now we have an 8. Integral from 0 to 2 pi. The square root of sine squared of t over 2 is just sine of t over 2. And then we need a 1/2, so it times another 2 on the outside. So we end up with negative 16 cosine of t over 2, and we are evaluating from 0 to 2 pi, which is negative 16 times, and then cosine of 2 pi over 2, so cosine of pi is negative 1, minus cosine of 0 is 1, so we end up with negative 16 times negative 2, which is 32.